Angular 19 has introduced the new powerful signal-based API, linkedSignal. In this video, you're going to learn everything that you need to know about linkedSignal, when to use it, why, and how it works exactly. Hello everyone and welcome back to the Angular University channel. I'm Vasco. So the reminder of this video is a lesson extracted from the Modern Angular with Signals course that I have been updating to Angular 19. In this lesson, I'm going to cover in detail the new linkedSignal API recently introduced in Angular 19. So without further ado, please enjoy the content. In this new section of the course, we're going to be introducing a new signal primitive called linkedSignal. So this is a signal primitive just like the signal itself, or computed, or effect. The reason why we are introducing it last is that we should only resort to it in certain special cases when the computed primitive is not sufficient. So let me start by giving you an example of when a linkedSignal could be useful. To see the linkedSignal primitive in action, we're going to be using this component here, linkedSignal demo component. You can see the component here in action if you head over here to the shopping cart menu. And as you can see, you can select a course from a list. You can choose a quantity of licenses and you can add it to the cart. So a very simple screen that we have here, but this will allow us to illustrate the use of the linkedSignal primitive. Now, let's have a look here at the quantity field. Let's say that we would like this quantity field to be set to a certain value depending on the value selected here for the course. So let's say that we would select here Angular for beginners. Then in that case, we would like the default quantity to be 10. If it's the signals course, we would like the default quantity of licenses to be 20. And if it would be SSR, we would like the default quantity to be 30. So we really want the quantity field to be a derived value from the selected course field. Let's then have a look at how the current implementation of this demo component works. So we have here our courses with the title, a code for the course, and the default quantity. Then we define here a signal selected course. So this contains a string, which is the code here of the selected course. So it's going to be one of these three values, and we have initialized it here to the beginner's course. Then we have the quantity field itself, also a signal, and it's currently being initialized to the value 1. Notice that both of these signals, selected course and quantity, are writable signals. And we need to make sure that we keep them that way, because the user can change the quantity using the user interface, and he can also change the selected course. Now let's see how can we implement the new feature that says that this field, quantity, should be a derived value calculated from the selected course. Well, one thing that you might be tempted to do is to use here a computed signal. But the problem is that computed signals by definition are read-only. So you would not be able to set the value of that derived signal. Another natural way that you might want to implement this is by using an effect where you detect changes in the source signal, and then as a response to that side effect, you change the value of the target signal. As you know, that's usually something that we would like to avoid. In general, we don't want to write effects that modify the values of other signals. That could create all sorts of weird scenarios and errors, including an infinite loop. This could accidentally break your application in certain circumstances. So instead, what we're going to be doing is we're going to be using a linkedSignal. So how does this work? This is a new signal primitive. The result is going to be a writable signal. Now let's pass it here a configuration object. The configuration object is going to take two key properties, the source and the computation. The source defines what set of source signals trigger the calculation of a new value of the linkedSignal. So it's a bit like a computed signal. It can have one or more source signals. Now, if you want to define a single source signal, in this case here, selected course, you can point to the signal like this dot selected course, and we would have here a valid source for our signal. I'm going to show you here an alternative notation right now just to fix the compilation error. Let's also define here a computation function, and I'm going to tell you all about it in a moment. Right now, what is important to understand is that this is going to return you the new value of the linked signal. So for the moment, let's hard code this to 1. Let's make the quantity always emit the new value 1 whenever the source signal changes. So as you can see, our code is compiling correctly. So we have here our first linked signal. As you can see, quantity is a plain writable signal. We can set values to it, we can update it, etc., just like any plain writable Angular signal. Now let's have a look here at how to define multiple source signals in our linked signal if we need to. So in order to define multiple source signals, we would need to pass in here a source function instead of a single source signal. Now this function should be returning an object with multiple properties. Each of those properties is going to be a source signal. So here is how we can do this. We're going to wrap here the return here in parentheses. We're going to make this an object, and we are going to give it here a property. We're going to call it the course code, and the course code property is going to point to a signal, in this case selected course. If we would have multiple source signals, we would add multiple properties to this object, and whenever one of the source signals will trigger a new value, then the computation is going to get triggered again. Now let's talk about the computation function a little bit more. So we are going to get here two arguments. One is the new source value, and the second argument is the previous value of the source. The previous value is going to come in handy whenever you have a situation where the next value somehow depends on the previous value. Let's now define here our computation function. We're going to do so in the following way. I'm going to add in here some logging so that we can see what is going on. We're going to be logging the source and the previous arguments of the computation function. And then we're going to find here on the courses array the course that has this particular new code. We're going to grab here the default quantity, and we're going to define here a value of 1 as a default in case that we did not manage to find a default quantity here on the courses array. And with this, we have finished the implementation of our linked signal. Let's go ahead and let's see it in action. So if I select here a new value of the course, we're going to see that the default quantity is getting updated, and we can see that we are logging the new source value, and also we are logging here the previous source. So if I change here to the third course, we're going to see that this gets set to 30. I can still change this and add to cart, and the new quantity is getting updated correctly as expected. But if I now reset here and I choose a new value, then the quantity is going to be reset here to the correct value as expected. So as you can see, the linked signal primitive, it's really a mix between the computed primitive and a plain writable signal. The result of linked signal is a writable signal, so you can update it as much as you want, but its value, it's also linked to a series of source signals. If one or more of the source signals get updated, then the computation function is going to get triggered again, and the output value is going to be the new value of the linked signal. So when to use this new powerful primitive? Well, in this type of reset scenarios where the value of one signal needs to be reset depending on the value of another signal. That's a typical use case for linked signal. Other than that, I wouldn't expect this to be used systematically everywhere in your application. Usually, if you want to calculate a signal that depends on another signal, you are better off starting off with computed. If by some reason you see that your application needs in certain circumstances to update the value of the computed function, then you can upgrade your computed into a linked signal, but I would probably not resort to it by default to create computed signals. I think that computed signals are better to be kept read-only unless it's absolutely necessary to write to them as well. As you can see, the linked signal primitive solves in a very elegant way certain use cases that were before hard to implement in a declarative way when using Angular signals. I would expect though that this primitive to be used only occasionally in your Angular applications in certain use cases like the one that I have presented here in this video, where you want to reset the value of a signal based on a source signal. That's the typical use case. In general, I believe that most of the signal primitives that you should be using in your Angular application should be the plain signal primitive and computed. Those should be the most frequently used, and only occasionally we should have to resort to linked signal or even effect. In a nutshell, you can essentially think about linked signal as a writable computed.